Hello students, welcome to another session of Theory of Equations. In the last class we have studied about some basic concepts related to theory of equations. So let us extend this discussion further in our part 2, so which is proceeded with these topics, which are key points to be remembered in solving an equation, where we will come across domain of an equation, extraneous roots, laws of roots. After that we will see graph of a polynomial function. So how it will proceed? So let us concentrate upon these topics. So let us start with the domain of an equation. So in solving the equation we have to remember these key points. So key points to be remembered while solving an equation. First one, domain of an equation. We know very well that in class level we have come across the concept called as a domain. So what is a domain in simple terms? Domain is nothing but the input values which are to be given to the function, and you know about the range also. Range is nothing but output values we are going to obtain after giving this domain values. Well, before solving this domain of an equation, that means for an equation, so we have to check whether these values are suitable for the given condition or not. Let us discuss with a small example. F of x is a function where it is equals to x square. Now, for what values of x we are going to get the values of this polynomial, that means function. So, we are going to get the domain of all the real numbers. All the real numbers. For all the real numbers we are going to get this value. Similarly, if we take one more example, 1 by x. G of x is equals to 1 by x is given. Can I take all the real numbers here? No. Why? Because if you take real numbers, I have to consider 0 also. If I keep 0 in the denominator, can we define this function? We cannot define. That means the domain of this polynomial is going to be r minus 0. That means we have to exclude 0. Except this 0, it is suitable for every other number. Let us take one more example. F of x is equals to 1 by x minus 1. Now can I define this function for this particular expression? No. I cannot take all the real numbers, but I can take number which is not defining this particular. I have to exclude that number. So which number is giving that undefined term here? Thus for which value we cannot define the value expression? For x is equals to 1. If I keep 1 here, 1 minus 1 is going to give 0. So that means I cannot define this function. That's why I have to exclude 1. So this is going to be the domain. So this will give us domain of an equation. This is a small example. Now, if you take some other examples where we have expressions like this. F of x is equals to x square minus 3x plus 2 by x minus 1. Now, whatever the x value we are going to consider for this solving of an equation, it must be suitable for both the values. That means if I consider 1 here, I can keep 1 here, but it is not defining this term. So when I cannot be able to define this term, so I cannot use that x is equals to 1 here. So I have to exclude that one. Now, so the domain of this one is going to be r minus 1. That means for this equation, for this function, this I cannot choose this one value. That means this is going to be the domain. Now let us solve this equation. X square minus 3x plus 2 by x minus 1 equals to 0. Normal procedure, x square minus 3x plus 2 equals to transpose is 0. That is transpose this x minus 1, it will become 0. Now factorize this one, you get the factors as x minus 2 into x minus 1 equals to 0. But can I consider x minus 1? That means x is equals to 2, x is equals to 1 will be the values. Can I consider x is equals to 1 as the root of this equation? I cannot consider because I have excluded 1 from this one. That's why I should not consider. Then what will be the solution of overall equation? X is equals to 2. Understood? So x square minus 3x plus 2 by x minus 1. I have to select the domain which is suitable for both the expression. Both the numerator expression as well as denominator expression should be satisfied. If any one of them is not satisfied, I should not take that value. So I have to abide by this domain value. So x minus 1 is the denominator. I have chosen domain of x belongs to r minus 1. So this is a domain. I have to follow the same domain. Take the same domain and solve the upper part of the equation. You are going to get these two zeros. But I should not consider x is equals to 1 as a 0 because I have excluded in the domain. So that's why this is going to be the solution. So x is equals to 2 is the only solution for this equation. So let us take one more example. Let us take one more example. So where x cube minus 4x square root of x square minus 1 equals to 0. Now I have to choose the domain values for this one. So what will be the domain for this equation? So make sure that you have two expressions here, x cube minus 4x and the square root of x square minus 1. So whatever the number you are choosing, it should satisfy both the equation. I should get the solution exactly. Now for what values of x, I will get the positive value here. If I keep 0 here, I am going to get negative. So in the square root, I should not get negative. There is a condition. For every other value of 0, I am getting the solution. So that's why. So what I have to do is, so take this x square minus 1 and whatever the value we are going to get, it should be positive or it can be equal to 0 also. If I keep 1 here, 1 minus 1 is going to be 0. I am getting still the solution. So it must be greater than or equal to 0. Then x square is greater than or equal to 1. Then what will be the x value? Based on this condition, x is belongs to minus infinity, minus 1, closed interval, and here is open interval. Union, closed interval, 1, comma, infinity. That means for these values, this is going to be positive. So this should be the domain. Now let us solve the problem. X cube minus 4x square root of x square minus 1 equals to 0. Transpose the term. X cube minus 4x equals to 0. Take common x. X square minus 4 equals to 0. X is equals to 0, x square is equals to 4. Then x is equals to plus or minus 2. But x is equals to 0 should not be the solution. Why? I have excluded in the domain. The domain of this particular equation has been already chosen. That's why from this, whatever the solution I am getting, it should satisfy this domain. So this will be the domain of an equation. Because of that reason, this is only the solution. So this is the second example. Now, after discussing this domain of an equation, the second one is extraneous roots. What is the meaning of extraneous roots? In simple terms, extra root. Extraneous root, nothing but extra root. So we are getting extra root. How we are going to get extra root? So we have an example, root x is equals to x minus 2. How do you normally solve this equation? Squaring on both sides. squaring on both sides, you will obtain root x whole square x minus 2 whole square, that means a minus b whole square expansion, x square minus 4x plus 2, or you can take x minus 2 whole square as a equation. Now x square minus 4x plus 4. Now solve this equation. X square minus 5x plus 4 equals to 0. When you solve this by factorization, you will get the answer as 4 into x square, 4x square, such that minus 4x minus x. X square minus 4x minus x plus 4 equals to 0. X is common here. X minus 4, here minus 1 is common. Now x minus 1, x minus 4 equals to 0. Now x is equals to 1 comma 4 will be the zeros, that means the roots of this equation. Now coming back to the question, if x is equals to 1, is it satisfying the condition? No. How? What is on the left hand side? Square root of x, square root of 1. Here 1 minus 2, 1 minus 2 how much? Minus 1. Are they equal? They are not equal. Now if we substitute x is equals to 4, square root of 4, 2. Again on the right hand side I have 4 minus 2, 2. Are they equal? Yes, they are equal. That means only one root is satisfying. So this is the extra root I got. So that is the concept of extraneous roots. So while solving an equation, you will get some roots which are not actually satisfying the given condition. So we have to exclude such roots. Quite opposite to this one, extraneous roots, we have one more concept which is called as loss of root. What is that loss of root? Let us see. Loss of root or loss of roots. Take an example. X square minus 2x is equals to x minus 2. This is one example. Now, when solving this equation generally, what you will do, you will take common between these two terms, you will get x minus 2. So x minus 2 upon division, you will get cancelled, x is equals to 1. But what type of equation we are having here? Both the expressions are given. So we have to transpose this one, then we will get a quadratic equation. So quadratic equation should have two roots, but only one root we got. So what happened? Loss of root occurred. So then what is the actual process we have to do? This is the wrong procedure. What is the actual procedure we have to follow? So we have to follow that x square minus 2x. This x minus 2 should be transposed. Then you will get x square minus 3x plus 2 equals to 0. Upon simplification, you will get x minus 1 into x minus 2 equals to 0. X is equals to 1 comma 2 are the roots of an equation. So both the roots we got according to the degree of this term. That means quadratic equation 2 roots, here also 2 roots we got. So this should be the process. So key points which we have to be concentrated. So while solving an equation are domain of an equation, we have to choose a domain. So domain of an equation nothing but an equation contains expressions or functions, different function. It can be between numerator and denominator, or in a product you may have rational and irrational product. So in such conditions we have to decide the domain which are satisfying both the functions. Similarly, extraneous roots, extra root, we are getting some extra root, so which is not satisfying the given condition, initial condition. The third one, loss of root. So here when we are solving an equation in a hurry, in a simplification process, so we have to be very careful by seeing the degree of a polynomial or equation, so that it can give exact number of roots. If it is not giving exact number of root, think that you are doing somewhere some mistake. So these are the subtopics under key points to be remembered. while solving an equation. Okay, the next topic is graphs of polynomial functions. Graphs of polynomial functions. So what is this graph of polynomial functions? Already we come across in the starting video that, so what is the nature of graph of a linear polynomial? It is a straight line. Quadratic polynomial, it will be a parabola. Cubic polynomial, it is a curve which is touching the x-axis at 3 different places. Similarly, the remaining others. Now in this graphs of polynomial functions, we shall see where the curve is falling, where the curve is rising, based on some conditions. To discuss this one, let us recall the standard form of the polynomial function. So f of x is equals to an x power n, an minus 1, x power n minus 1, and so on up to a naught. Here an x power n is called as the leading term. Leading term. So what is the meaning of, what is the definition of leading term? So leading term is nothing but in a given polynomial, whichever the term contains the highest degree in that polynomial. So that term is going to be considered as the leading term. So in this leading term, this an is called as the coefficient, but here we call it as leading coefficient. So based on this n degree, based on the degree, so we will say degree here and leading coefficient. So we shall see 4 cases of a polynomial function, how they are acting, how they are representing the graph. The first one you can see on the screen. So where n is odd and an is positive. N is odd and an is positive. So when n is odd and n is positive, so you can see that the curve is falling to the left side and it is rising on the right side. So that is going to be the nature when n is odd and an is positive. Now second case, still the n will be odd and an will be negative. So if an is negative, that means n is odd and an is negative, how? It's quite opposite phenomenon will occur. So what is that one? So it will rise on the left side, but it will fall on the right side. Quite opposite. In the starting we have seen the first case, it was falling on the left side, rising on the right side. But in the second case, it is rising on the left side, but it is falling on the right side. Next, third one, if n is even and an is positive. So what happened? You can see on the screen, just like you can see the curve like a W. So where at both the left and right side it is rising. It is rising on the both left side as well as the right side. If you go to the fourth case, that is called as where n is even and an is negative. In this case, just reverse phenomenon will occur. What is that one? It will decrease or fall on both the sides, both on left side as well as the right side. You can see on the screen. So this is how the leading coefficient will act in deciding the graph of this polynomial function.